let's take a few minutes to look at the second derivative test. And before we start that, let's take just a little reminder trip about where a function is decreasing or where it is increasing. And if that derivative is increasing, the increasing means that it's getting more and more and more positive and larger. So as you can see, these are negative slopes getting less and less negative. They hit zero, and then they hit positive, and they get more and more and more positive. So as x's were going from left to right, the derivative was increasing everywhere there. We can use that same argument for decreasing, that you have the values of the derivative are decreasing. Here it's a large positive number, less positive, less positive, less positive, zero, negative, more negative, more negative, more negative. So as x goes from left to right, those derivative values are decreasing. You should hit pause and think about that for a little bit. Now, when we look at these in general, the second derivative test is telling us that if we evaluate that at a given value, we have a relative min if the second derivative is positive. So if the second derivative is positive, it's saying the first derivative is increasing everywhere on that interval, and so therefore you have a min. If you have, and I'll write max here, if the second derivative is negative, that means those derivative values are decreasing from left to right, becoming more negative, and you are then concave down. And so you have a relative min if the second derivative is greater than zero, so it's concave up, and you have a relative max here if the second derivative is less than zero. Now, what we need to add to this that I don't have typed on here is that if f double prime of c is equal to zero, you get nothing. You have no conclusion. So more is happening there than a simple second derivative test can tell you. If you remember from our first derivative, we had a frame for problems. And we're going to do that same idea when we look at the second derivative. We have a function, so we're going to take that function and find the derivative first. So our function, first derivative, is, bring the 5 down, you get 15 x to the fourth minus, bring the 3 down, 60 x squared. It is the second derivative test, so let's go ahead and find the second derivative right away. Bring the 4 down, you get 60x cubed. Bring the 2 down, you get minus 120x. Now we need our critical values, so the first step is to do those derivatives. The next one is we're in a search for critical values. And C are those critical values, and the ones that are named up here, these are all our critical values. And so take 0, set it equal to the first derivative. I'll go ahead and write first derivative. And I'm going to factor as I go here. 15x squared times x squared minus 4. Let's go ahead and check that. 15 times x squared is x to the fourth. 15 times negative 4, then you get that. So the factoring is good. Now let's go ahead and solve these. You can keep factoring. That is the difference of two perfect a square number. So here we go. X is equal to 0 from the first factor, negative 2 from the second, and 2 from the third. Now what the second derivative test tells us, we're going to check them. So let's do f double prime of 0, f double prime of negative 2, f double prime of 2. Remember, once we check those and we have numbers here, we can come all the way up here and then up here check our decision rubric. And so when we substitute 0 in, we get 0 minus 0. We're using the second derivative, so don't forget you're substituting in here. Don't substitute into the first. For the next one, we get 60 times negative 2 cubed minus 120 times negative 2. Use your calculator. You get negative 240. And then go ahead and do for 2. You get 60, 2 cubed minus 120 times 2. You get 240. Okay, so now we need to make a decision. This guy equal to 0. No conclusion. we can't do anything with him. This guy's less than 0. Less than 0 means can't hold water, faces down. We have a relative max. And this guy, the last one, greater than 0, does hold water. We have a relative min there. Now, we do need to show how we know these are critical values. And so we're going to go back and add this first derivative sign chart, -2, 0, 2. Split them up. Test values. Test a value here, here, and here. Each of those spots. When you do that, you get positive, negative, negative, positive. That middle one's weird, right? But that's okay. We're going to see where that comes into play in a second. And so we need to have our final conclusion. Here we have first derivative. These are critical values. Yes, we agree they're critical values. F double prime of 0, no conclusion. That makes sense, right? Because of that first derivative. And then the second derivative here, we have max and mins. Here it's going up and then down. So there's a relative max at -2. Tells you here. We have a relative min at 2. That tells you that here. Now, so we have to actually name and say we have an answer. So we've got a conclusion. Sorry, I didn't leave myself enough space. We have a relative max of, and we have a y value at x equals -2, and a relative min of, and what is that y value, at x equals 2. So that's your conclusion, but you have to find the y values. So you've got to go back into the original function and find what those values are. At -2, it is 64, and at 2, it is -64. So be careful to give a conclusion when you're all done, not just circle something on your paper. Let's do this next one. We're asked for critical values, relative maxes and mins, increasing, decreasing, but this one we're given an interval, so that's interesting, right? So we're not doing it everywhere, we're only doing it on that interval. Let's take the first derivative. You get 4x cubed minus 48x squared. Set it equal to 0. We're in the search for critical values, so you're going to factor. Check your factoring by going backwards. So x is 0 and x is 12. These are the critical values. Let's test them. When we do that, we're going to test a value over here. We're going to find that we're negative in the center. So we're testing something here. Test something here. This is also negative. Test something here, and you're going to get a positive. Doesn't matter what value you pick. You know that from your first derivative test. And so our critical values are 0 and 12. Now, let's go ahead and do our second derivative. And when we do the second derivative, we get 12x squared minus 96x. And let's check the second derivative at each of those critical values. When you check it at 0, you get 0. So no conclusion. When you check it at 12, you get 12 times 12 squared minus 96 times 12. That gives you 576, which is greater than 0, which means it holds water. So you have a relative min there. You're going to need a y value, so go ahead and find that y value before you can give any kind of conclusion about relative min or max. So substitute 12 back up into the original function. When you do that, you get a whopping -6907. So let's go ahead and write our, now that we've done all the work, let's see if we can get all of our information. Our critical values, x is 0 and 12. Relative max, there isn't any. You do need to say that. When it asks you for relative min and max, if there isn't one of them, you have to say it. The relative min, yes, of -6907 at x equals 12. Where is it increasing and decreasing? On 2050. And so we need to take a look at that next. And so we have on, for both of these, from 20 to 50. Where is that happening? We know from the first derivative test that it is decreasing from 20. Oh, I was using negative numbers. It's decreasing nowhere. Oh my gosh. Give me rid of that. Never decreasing on this. It is increasing. I was all ready to bunny hop that number line. Increasing on from negative 20, positive 20. Here up, it's increasing everywhere. So it's increasing everywhere over there. So that's interesting, right? And is it concave or concave up or concave down over there as well? And it is going to be concave up. And we have concave up because of the work that we did over here. So that's interesting. Sorry about that. I was ready to do the whole number line. And so we only had to do from 20 to 50. So watch that when you're doing your homework to make sure you pay attention to the intervals it's talking about. So that's it. Hope you're having a great day.